Hello everyone, myself CH Srinivas Sir, Associate Professor in AS Engineering Academy. I will be sharing a structured preparation strategy for cracking ISRO examination. And I have been teaching and mentoring for the GATE aspirants over the decade, and my expertise lies in data structures, algorithms and C programming. So when coming to the concept of preparation strategy for ISRO examination, here I will be sharing a structured preparation strategy for programming, data structures and algorithm subject. So one of my colleague, Mr. Ramesh Masuna, he already introduced in the introductory video. He clearly mentioned that there are 200 plus questions are there from algorithm, data structures and programming. So ISRO exam has started in 2008, means like we collected question papers from 2008. So from 2008, starting from 2008 up to 2023 papers. If you could analyze these PYQ questions, you can understand that programming, data structures and algorithms all together, we are having 200 plus questions, friends. Okay, 200 plus questions. So that is the importance of the subject. Here I am taking this opportunity to explain questions came from programming and data structures. So if you observe these questions and if you compare these questions with the GATE previous year questions, 90% questions came from directly from the GATE previous year question papers. So my sincere advice to my student is you always give preference to GATE previous year questions, friends. Okay, you can always give preference to GATE previous year questions. So without wasting time, let me explain some of the model questions they asked from the data structures and programming concepts. Okay. So when we are talking about data structures, so we are having two types of data structures. One is called linear data structure, another one is non-linear data structures. One is linear data structures, another one is non-linear data structures. Where in the linear data structures, we will discuss concepts like array, stack, queue, linked list. Where in non-linear data structures, we will be sharing the information about tree concept. Under tree, specifically we are focusing on binary tree, second one binary search tree, next AVL tree, after next topic that is hashing, and finally we have graph concept, where in graphs we have topic like breadth first search and then depth first search. So just I am dividing complete data structures into two parts. One is linear data structures, another one is non-linear data structures. Now I will be sharing the information like what area they focus so far from 2008 to up to 2023 question papers, friends. Okay. So if you see PYQ questions, most of the questions came from tree concept, friends. Okay, most of the questions came from tree concepts, and I can give the first priority. The first priority. After second priority is, we can say second priority is stack concept, and third priority goes to hashing, and fourth priority that is graph concept. Next, fifth priority, see this stack and queue, they are interrelated topics. Most of the questions are interrelated with each other, so I can combine those two topics and I can consider the second preference, friends. Okay. After linked list will take fifth preference, where array concept will take sixth preference. Right, friends. So while you are starting preparation for data structure subject, you always start from tree concept, friends. Okay. So it is highest weightage topic in data structures. So now without wasting time, I'll explain what type of questions they ask so far and tree concept, so that you can also prepare in that order. Okay. See, by observing PYQ questions, I divided questions of tree concept into several categories, friends. Okay. Just observe what type of question they asked so far, so that you get clear idea about how to prepare for tree concept. For the given, for example, if they provide for the given binary tree, they will ask questions like this: what is? So you can also read the table in this order. For the given binary tree, what is in order means we need to find in order traversal of the given binary tree, and what is pre-order traversal, what is post-order traversal. Clear, friends? Okay. They will provide one binary tree diagram. For that binary tree diagram, we need to compute in order, pre-order, post-order traversals, and also we need to understand how to find converse of in order traversal, and converse of pre-order traversal. You can imagine converse of pre-order, converse of post-order traversals. Okay, let me write them: converse of in order, and then I can say pre-order, post-order. So this is the one area where they are focusing. Clear, friends? Okay. For the given binary tree, how to find in order, pre-order, post-order, then how to find converse of in order, converse of pre-order, and converse of post-order. That is the first way of asking question. And the second way of asking question is, for the given binary tree, they will ask questions based on properties. Okay, that is properties of a binary tree. Properties of binary tree. For the given binary tree, they will ask properties of binary tree. So properties of binary tree means what type of properties they will ask? They will ask like how many maximum number of nodes are possible, max number of nodes, comma, min number of nodes, right, friends? They will provide one binary tree. They will ask how many maximum number of nodes are possible, how many minimum number of nodes are possible, and also they will make the relationship between internal nodes and then internal nodes and leaf nodes. Okay, so these are the two types of questions they are asking in binary tree, friends. Okay, one is tree traversal, another one is properties of binary tree, and the second one, there is one important tree that is called KARY tree. KARY tree. This topic is most frequently repeating in the ISRO paper as well as GATE examination paper, friends. Okay, what is KARY tree? We will discuss little later. In KARY tree also, they will ask questions based on KARY trees, properties of KARY tree. This is the most important topic we need to focus. Properties of KARY tree. Sometimes they are asking numerical questions also. So in KARY tree, there are some important fundamental properties. Based on properties, we can solve this numerical questions also, friends. Okay. After KARY tree, next tree which we need to discuss, that is binary search tree. Binary search tree. So the way how they ask in order, pre-order, post-order for binary tree, here also they will ask in order, pre-order, post-order of the binary search tree. But I don't want to mention that point again here. And here important point is in order traversal, of binary search tree is always in ascending order. In-order traversal of binary tree is always in ascending order. This is the most important property. So therefore, they frequently ask the question. They will provide one binary search tree. They will ask what is the in-order traversal. So in-order traversal of binary tree always in the ascending order, friends. Okay, you just remember this one, ascending order. And other way of asking questions in binary search tree is focusing on time complexities. Focusing on time complexities. So when it comes to time complexity, there are 4 ways of asking questions, friends. Okay, the first one is inserting an element into binary search tree. How much time complexity will take? Means insertion operation on binary search tree. How much time complexity will take? And second one is deleting an element from binary search tree. Deleting an element from binary search tree, how much time complexity will take? Third one, that is searching an element from the binary search tree, how much time complexity will take? Searching operation. And fourth one, friends, that is construction. Construction of binary search tree, how much time complexity will take? Clear, friends? Okay. So whatever time complexity questions they are asking, those questions also related for AVL tree also, friends. Okay, AVL tree also. For binary search tree and AVL tree, they are focusing questions like this: time complexity for inserting an element, time complexity for deleting an element, and time complexity for searching an element from binary search tree, and time complexity for construction of binary search tree or AVL tree. Clear, friends? Okay. So these are the varieties of questions they are frequently asking. In addition to these questions, few more questions also I want to introduce. These questions, whatever I have written here, they are straightforward questions, friends. Okay, they are straightforward questions. Sometimes they are asking application oriented questions also. For example, if they provide pre-order traversal and then in-order traversal, they will provide pre-order traversal and in-order traversal. By using pre-order and in-order traversal, we need to construct binary tree, friends. Okay, so we have to construct binary tree. Construct binary tree. So in the exam, they will provide in-order traversal and pre-order traversal. They will ask you to find the height of that binary tree. In order to find height of that binary tree, first you need to construct the binary tree, friends. Okay, so there is a procedure for constructing a unique binary tree with the help of in-order and pre-order. Similarly, they will provide post-order traversal along with in-order traversal. So by using post-order and in-order traversal, again we can construct binary tree. Okay, again we can construct binary tree. Sometimes after constructing binary tree, since we know pre-order and in-order, therefore they will ask what is post-order. What is post-order? As we know post-order and in-order, and we construct binary tree here, so by using that we need to find pre-order traversal also. Right, friends? Okay. So here pre-order and in-order, post-order and in-order, these are only on binary tree concept, friends. Okay. Okay, these are related only binary tree concept. But by using pre-order and post-order, we cannot construct unique binary tree. So that is when they don't ask questions by using pre-order and post-order construct binary tree like that. Okay. So therefore, we cannot take this part, pre-order and post-order and construct unique binary tree is not possible. But there is one concept that is called construction of full binary tree. See, by using pre-order and post-order, we can construct full binary tree, friends. Construct full binary tree. If you have any questions, kindly listen one more time. See, by using pre-order, in-order, or by using post-order and in-order, we can construct binary tree. But if they provide pre-order and post-order, we cannot construct unique binary tree, but we can construct unique full binary tree. So what do you mean by unique full binary tree means? A binary tree is called full binary tree if every internal node is having exactly 2 children. Okay, a binary tree is called full binary tree if every internal node is having exactly 2 children. Or else we can also say if all levels of binary tree are completely full, that is also called full binary tree. So there are 2 definitions we are having for full binary tree. So one is every internal node is having exactly 2 children, or else we can say all levels are completely full, we can also call it as full binary tree. Okay, so these are 2 types of definitions are available for full binary tree. I hope you understand different types of asking questions, friends. Okay, so generally in ISRO they ask only 1 mark questions, therefore these are the only important models and tree concepts. Just go through once again all the models. So these are the models, different types of models. Now I'll take one by one, I'll explain some important concepts, so that you'll get clear idea about how to prepare for tree concept. Okay, let me focus on how to find in order, pre-order, post-order traversal of the given binary tree. How to find in order, pre-order, post-order of binary tree. See, since the weightage of each question is only 1 mark, we are supposed to answer question very quickly with the help of possible shortcut methods. Here I am taking the privilege to explain only shortcut methods, friends. Okay, not regular procedure. Okay, because only 1 mark questions these are, therefore I want to solve problems with the help of shortcut methods. Okay, for example, let us consider a binary tree. A, B, C, D, E, F, G, H. Suppose let us consider this is the binary tree they provided, right, friends? Okay, for this binary tree I want to find in order, pre-order and post-order traversals. So before understand this question, you first understand how the node structure is defined internally for the given tree. For example, if you consider this node in a binary tree, this node consisting of 3 parts, friends. Okay, 3 parts. Let me draw the diagram, you'll get clear idea. For example, if I define one user defined data type, name of the user defined data type is I am calling it simply box. Okay, here also I am taking same box like this, where this user defined data type consisting of 3 parts. Clear, friends? Okay, so how do we define this user defined data type? Means suppose if I give name of that box is something like node, name of that box I am calling something like node. So node is my own data type. It is not like as existing data type integer, character, float. It is my own data type. But how do I inform to the compiler that this is my own data type? Means I can take help of a keyword is called struct keyword. Okay, therefore I can take struct keyword. By using struct keyword, I am informing to the compiler that this node is a user defined data type. Then that node is having 3 members. One is called LPTR, another one is called data, one is called LPTR, another one is called data, another one is called RPTR. Clear, friends? Another one is called RPTR. So let me show those values now. Here we are having LPTR, data, and then RPTR. What is the purpose of LPTR? Means LPTR is a left pointer which is pointing to the left child, and RPTR is a right pointer which is pointing to the right child of that node. So suppose for every node is having particular address, let it be address is 100, its address is 200, its address is 300. Clear friends, okay. Now data, suppose consider according to here, suppose if I consider this node address is equal to 200, let it be in this node address is 200 and this node address is 300 friends. Let us assign addresses in that fashion. Just I am assigning addresses randomly like that, okay. 600 and then it is 800. Is it clear friends, okay. So for every node there are two pointers, one is left pointer, another one is right pointer, where left pointer contain address of left node, means left child node. So its address is 200, therefore I am storing address is equals to 200, right friends, okay. But basically when pointer is holding address, it must point into the target, therefore this pointer is pointing to target like this, right friends, okay. But who is sitting in the 200 location? B is sitting, right, therefore I can take here data is B, here data is B. Similarly, a RPTR indicates that right pointer which contains address of the right child. So let it be 300, so we can take it as 300. Then this pointer is pointing to 300 location, right friends, okay. So it is also user defined data type, therefore it is also having three members, that is LPTR, data and then RPTR, right friends, okay. Here also you can say LPTR, data and then RPTR. Now look at here LPTR, so it means that if you look at B node, for B node left pointer is pointing to 400, right pointer is pointing to 500. So therefore we can say it is address is 400 and then its address is 500. Whereas for this node left pointer, it means that data is C, verify is left child is available or not, no, right, there is no left child is available, therefore left pointer is pointing to null, whereas right pointer is pointing to 600 location. So in this way I can represent the tree in the form of user defined data type. The reason why I am explaining this part means, just observe, if you understand the structure, tree traversal concept is very simple friends. You can answer tree traversal concept within 30 seconds also, okay, within 30 seconds also. Try to understand how I am doing the problem. Suppose it is pointing to 400, again there is a link, it is pointing to 500, right friends, okay. Here it is null link, it is not pointing to any node, it is pointing to 600 location. In that fashion, just if you observe friends, if you traverse the tree, just imagine I am taking here left pointer is pointing to null, here right pointer is pointing to null, means all leaf nodes having null link pointers, all leaf nodes are having null link pointers, okay. So these are null link pointers, clear friends, okay. Then whenever we are traversing the tree, every node we are touching 3 times, just observe how we are touching 3 times. While touching 3 times, what we will do, just observe friends, if you touch first time, you can write it as a pre-order traversal. When you touch first time, that is nothing but pre-order traversals, okay. So I am indicating one indicates pre-order traversal, okay. If you touch second time the same node, you can write in order traversal, If you touch the node third time, you can write in post order traversal, right friends, okay. Just remember this rule so that you can easily answer get in ISRO paper questions friends, okay. Yes, when we start traversing tree, it is the first time I am touching, right friends, it is the first time I am touching A, therefore I can write in pre-order traversal, so that is A, right friends, okay. Afterwards we are moving towards left subtree, it is the first time I am touching B, therefore I can write in pre-order traversal. Afterwards again it is the first time touching D, write in pre-order traversal. Then we are reaching null link, afterwards we are coming back and we are touching second time friends, okay, we are touching second time. When you touch node second time, you can write in order traversal, so write in order traversal, that is nothing but D, okay, D. So afterwards it is null link pointer, it is third time I am touching the node friends, okay. Third time means obviously we can write in post order traversal, like that. If I continue, it is second time, that's why write in order traversal, it is first time, write in First time means you can write in pre-order traversal, right friends, okay. Afterwards it is the first time, write in pre-order traversal. It is second time in touching, write in order traversal. It is third time, hence we can write in post order traversal, right friends, okay. Afterwards it is second time, write in order traversal. It is a third time, write in post order traversal. By continuing this process, it is a third time, so hence I can write in post order traversal. Second time, write in pre-order traversal, sorry, please excuse me, write in post order traversal, sorry, in order traversal, that is A. Afterwards it is the first time I am touching, write in pre-order traversal. Second time, write in order traversal. First time pre-order, again first time pre-order, that is GH in pre-order traversal, right friends, GH in pre-order traversal. After the second time touching, therefore write in order traversal. Third time, write in post order traversal. It is second time, write in order traversal. It is third time, it is also third time friends, okay, that is GC. Afterwards it is a third time, that equals to A. Clear friends, okay. So verify quickly, pre-order traversal means ABD and then EF CGH. So ABD EF CGH. Whereas in order traversal means first you have to finish left part and then visit parent and then finish right part. Means in order traversal, for every node first process left subtree and then visit that node and then process right subtree. For example, in order traversal, for this node A, first finish left part, means before reaching A, its left part completely visited friends, okay. For example, here in order traversal A, so before reaching A, verify all left subtree nodes are completed or not. Who are the left subtree nodes for A? D, B, E, F. So clearly D, B, E, F completed here. Clear friends. For every node, first process left subtree and then visit that node and then process right subtree. That is called in order traversal. Whereas post order traversal means for every node, first finish left and then right and then process that node. For example, if you take A, who is left means left part is this part and right means this is the right part. It means that this node we can visit only at the end friends, okay, at the end. So this is a shortcut method you can use so that you will get clear idea and we can answer questions very quickly in the exam also. Then from this, what type of question they will ask again? Sometimes what they will do friends, they will provide pre-order and in-order traversal. They will ask you to construct binary tree and they will ask what is height of that binary tree, okay. Or else they by using in-order and pre-order, they will ask what is post-order traversal also. Is it clear friends, okay? And one more point I want to explain here, that is, for example, if they provide only in order traversal friends, okay, only in order traversal. For example, I am saying in order traversal of binary trees ABC. Then how many binary trees will have same in order traversal? That is also one important area you need to focus. If the in order traversal of a binary tree is ABC, then how many binary trees will generate ABC? Okay, how many such binary trees will exist which will generating same in order traversals? So if they provide in order traversal ABC, how many ways I can draw that binary tree? Means, for example, if I take root node is B and here it is A and it is C. Now just apply in order traversal friends. If you apply in order traversal for this node, first process left A, so you are processing A and then visit B and then visit right. So therefore this is one binary tree which is generating same in order traversal. Similarly, I can take C and then B, A. Just apply in order traversal for this binary trees, you will get same in order traversal. So for every node process left, for this node process left and left is not there, then visit this node and process right, right is not there. Similarly, for this node process left already over, then visit that node, okay. And for this node process left already over, then visit that node and process right subtree. So like that, how many binary trees can you construct here, okay. So for the given 3 nodes, we can construct 5 possible binary trees friends, 5 possible binary trees. So there is a formula like that. Why 5 possible binary trees means you can construct, you will get clear idea. It is second one, right friends, okay? Or else if you ask me to draw one more, I can say A and then B and then C. It is third one friends, ABC. Or else one more I can say, that is C. Here I can take A, it is B. Just observe, for every node first finish left part, that is A. For A there is no left part, then visit that node B, visit that node A and then come to B, right friends. There is no left, then visit that node and there is no right also, then come back and visit C, ABC. So total I constructed 4 and one more is also possible, that is A, after C and then B. So for the given binary tree, for the given in-order sequence which contain 3 elements here, how many possible binary trees will have same in-order traverse means 5 possible binary trees. So there is one formula, number of possible binary trees for given in-order sequence of an element is, if the in-order sequence contains n elements, number of possible binary trees are 1 by n plus 1 into 2n Cn. So this is the way we need to understand number of binary trees. It is not only applicable for in-order traversal, even if they ask pre-order traversal. For example, if they provide pre-order traversal having elements something like A, B, C, then how many such binary trees are possible? 1 by n plus 1 into 2n Cn binary trees are possible. Okay. Even if they ask post-order traversal, how many binary trees are possible? Suppose if they provide A, B, C, number of binary trees having same post-order traversal, same formula friends, 1 by n plus 1 into 2n Cn. That is called Catalan formula. You no need to remember the proof of Catalan, just remember that formula. Is it clear? So this is one area where they are focusing on tree traversals. Is it clear? And the next one, as I mentioned, there is one important topic that is called KRY tree. So this is one area where they are frequently asking KRY tree friends. KRY tree. Let me explain what is the meaning of KRY tree. For example, if I draw a binary tree, just focus on these two binary trees friends, okay. So what is the meaning of KRY tree? KRY tree is nothing but every internal node exactly contains k children friends. Every internal node contains exactly k children. For example, in this binary tree, what are the nodes are internal nodes? I will show in the different color. So it is one internal node, second internal node, third internal node, it is a fourth internal node. Clearly every internal node is having exactly 2 children. So for the node, root node, we are having 2 children. Yes, it is the first child and it is second child. And for this node there are 2 children friends. These are 2 children. And for this node there are 2 children. Right friends, these are 2 children. Similarly for this node there are 2 children. If every internal node contains exactly 2 children, that tree is called 2ARY tree friends. That tree is called 2ARY tree. Can I say it is a 2ARY tree? Yes, we can say it is a 2ARY tree. Because this node is internal node having 2 children. This node is an internal node having 2 children. That's why it is also called 2ARY tree friends. 2ARY tree. But what about this one? Here every internal node contains exactly 3 children friends. Look at here, this internal node is having 3 children, 1, 2, 3 children. Similarly, this internal node is also having 3 children and it is having 3 children. So this type of tree is called 3ARY tree. That is 3ARY tree. So based on this concept, there is one important formula you have to understand. That formula is, in a complete KRY tree, if there are I number of internal nodes, I number of internal nodes, L number of leaf nodes, L number of leaf nodes. Then see, whenever they provided I number of internal nodes and L number of leaf nodes, there is a relationship between leaf nodes and number of internal nodes, friends. So they are talking about relationship between leaf nodes and internal nodes. They will provide options like first option, L is equals to n into, what is n here? Let me take n, let me ignore the n value, I into k minus 1 plus 1. Second one, number of leaf nodes L is equals to k into I minus 1 plus 1. Third one, number of leaf nodes is equals to I into k, whereas fourth option, number of leaf nodes is equals to I into k plus 1. Their options, friends. Actually, this formula is most important formula, friends. Okay, there are so many questions came from this topic. Okay, so I don't want to explain the formula like how to remember it, but I'll explain the process, friends, so that you'll get clear about this topic. Okay, just look at the process. It is one important area I am expecting question. That's why I am explaining this topic, friends. Okay. See, here I am representing I indicates that number of internal nodes. I indicates number of internal nodes. Whereas L indicates number of leaf nodes. Where K indicates that K R by tree. K R by tree. Right, friends? Okay. In our example, how many internal nodes are there? Just look at internal nodes. 1, 2, 3. Those are called internal nodes, friends. Okay. There are 3 internal nodes are there. And number of leaf nodes we have 4 leaf nodes. They are called leaf nodes, friends. Okay. 4 leaf nodes. Whereas in K R by tree, K is nothing but every internal node is having exactly K children. Here every internal node is having exactly 2 children, right? That's what is called 2 R by tree. Therefore, K value is equals to 2. Now, if you observe the previous options, whatever they provided, so one of the option may be looking like this: number of leaf nodes is equals to something like number of internal nodes into K minus 1 plus 1. Let me focus on this option, friends. Okay. Number of leaf nodes here how many? That is 4. Number of internal nodes 3. K value is equals to 2. 2 minus 1 plus 1, which equal 3 plus 1, that equal 4. 4 equals to 4. Only this is the option is matching, remaining options are not matching, friends. Okay. L into I in L is equal to I into K minus 1 plus 1, that is option A is matching, remaining options cannot match that answer, friends. Okay. So therefore, it is nothing but option A is the correct answer for this question. But my suggestion is don't remember the option, friends. Okay. You try to analyze how it is possible to get L is equals to I into K minus 1 plus 1, because based on that there are so many application based questions also there in the GATE and ISRO paper also. Let me explain how we are getting that formula. Suppose if I ask what is the total number of nodes for this problem, the total number of nodes, how do you get total number of nodes, friends? Just look at here, total number of nodes means, see, there is one internal node contributing 2 children, it is second internal node contributing 2 more children, third internal node contributing 2 more children. Therefore, total number of nodes means I can write like this: there are 3 internal nodes, each internal node is contributing 2 children. Okay, 3 internal nodes, each internal node is contributing 2 children. That's a 3 into 2. Extra I am adding plus 1, friends. Okay, plus 1. Let me justify why did I include 1. Okay, what is the purpose of adding 1? Observe, friends, how I am counting number of nodes. See, with respect to this node, how many children means first child and second child. So these 2 nodes are counted with respect to root node. I am not counting root node. Okay, with respect to this node, 2 children is counted, right, friends? Okay, therefore with respect to this node, again 2 children is counted here. With respect to this node, 2 children is counted, means 2 children counted how many times? 3 times. That's why I am writing 3 into 2. Okay, 2 children counted how many times, friends? 3 times. That's why I am taking 3 into 2. but which node is not counted means that equals to root node. That's the reason I am adding plus 1. This plus 1 is useful for root node count purpose. Okay. So in the place of 3, what I can say, that 3 indicates that number of internal nodes, but what did I mention number of internal nodes here, friends? I. Therefore number of internal nodes are I into, what about the 2? 2 indicates that kr by tree value of k, that is k plus 1, I into k plus 1. Here they are talking about total number of nodes, but actually our formula is expressed in terms of leaf nodes, right friends? Okay, they are not asking about total number of nodes, they are talking about number of leaf nodes. Is it clear, friends? Okay, number of leaf nodes. So therefore I want to bring number of leaf nodes from the total number of nodes. Okay, just observe how to express total number of nodes, friends. Total number of nodes, we can also write one more point, that is number of internal nodes plus number of leaf nodes. Am I right or wrong? Total number of nodes means number of internal nodes plus number of leaf nodes. For example, how many internal nodes here? 1, 2, 3 internal nodes. How many leaf nodes? 4 nodes. 3 plus 4, that equals to 7 nodes. Therefore this total number of nodes I am writing internal nodes plus leaf nodes. Since they are expecting value of L, so therefore L is equals to, bring I value to the right hand side, friends. Okay, by bringing I value to the right hand side, I can take I as a common, then I into k minus 1 plus 1 like this. So just bring I that side and take I as common, I into k minus 1 plus 1. So based on this model, means based on this formula, so many application based questions are there. I will introduce one problem they asked in the gate paper. So one time they provided like this, suppose number of leaf nodes is equal to 41, right friends, number of leaf nodes is equal to 41 and number of internal nodes is equal to 10, then what is the value of k they are asking? Simply substitute here, you will get answer. Simply substitute, I do not want to waste your time now. Simply substitute, you will get answer equal something like 5. Okay, L equal to 41, right? Bring 1 this side 40, 10 into 5 10 into k minus 1 is equals to 40, right friends? So 4 times get cancelled, k equals to 4 plus 1, that equal to 5. This is the one question they asked in the gate paper one time. Okay, other way of asking questions, just observe, friends. So one of the application based question they asked like this, in a binary tree, there are 10 internal nodes having degree 2 in a binary tree. There are 10 internal nodes having degree 2 and 5 internal nodes are having degree 1. Then how many number of leaf nodes are there? Then how many number of leaf nodes are there? So this is a question, friends. Okay, of course, it's application oriented question based on that formula. Even though if you remember that, even though if you forget that formula, you can answer this question by drawing binary tree, friends. Okay, because they mentioned that in a binary tree there are 10 internal nodes having degree 2. See, when it comes to the degree of a node in a tree is nothing but number of subtrees. For example, if I consider a binary tree like this, for this node, just observe here. For this node, if you observe, it is one subtree and it is another subtree. Clear, friends? Okay. So number of subtrees of that node is called degree of that node. For example, for this node also, what is the degree means how many subtrees, first subtree and second subtree. So degree of that node is 2. Similarly, if you consider this node where only one subtree is possible for this node, degree of this node is 1. Whatever degree of leaf nodes? Degree of leaf nodes are 0. So how do you define degree of a node in a binary tree? Means number of subtrees of that node is called degree of that node, friends. Okay. So clearly for this node there are 2 subtrees. It is first subtree, it is second subtree. That's why degree of this node is 2. Where for this node only degree is 1. right friends. Okay, now by keeping that point in your mind, if they ask question, directly can construct binary tree friends. Okay, so I can say number of nodes having degree 2. Just look at here, there are 10 internal nodes having degree 2, 10 internal nodes having degree 2. So therefore we can construct quickly 10 internal nodes having degree 2 friends. Okay, just observe, I have drawn exactly 10 internal nodes of degree 2 and 5 internal nodes of degree 1. So there are 5 internal nodes of degree 1. So 5 internal nodes means I can draw like 1, 2, 3, 4, 5. In that case, they are asking how many number of leaf nodes are possible for that problem. Now, how many number of leaf nodes are there means just count here, number of leaf nodes is equals to 11, right friends. Okay, if you want to do the problem like that, you will take time consuming process friends. Okay, the time consuming process, and suppose if they increase number of nodes, it is very difficult to solve the problem in this approach. In that case, you can apply the previous formula, number of internal nodes plus number of leaf nodes is equals to number of internal nodes into value of k in k-array tree plus 1. Observe how to use that application for solving this question. Okay, so we know that formula is total number of nodes. Total number of nodes equals to internal nodes plus leaf nodes. Please recall previous formula. Total number of nodes equals to internal nodes plus number of internal nodes plus number of leaf nodes is equals to number of internal nodes into value of k in k-array tree plus 1. Is it clear friends? That is the formula I explained. Now if you observe here, there are 10 internal nodes. Suppose you can call it as I1 internal nodes, and after having degree 2 means what is the k value here? K is equal to 2. Therefore 10 internal nodes of degree 2, you can write like this. Okay, I we are splitting in this way friends. I we are splitting into two parts, I1 and I2. So I1 internal nodes of degree 2 friends. Okay, therefore I1 internal nodes of degree 2 means you can say that is 10 internal nodes of degree 2, right friends, plus, and here 5 internal nodes of degree 1 plus 1. Clear friends. Okay, so there are two types of internal nodes of degree 2 and internal nodes of degree 1. Therefore 10 internal nodes of degree 2, therefore k is equals to 1 here, and 5 internal nodes of degree 1, so k is equals to 1. What is the purpose of plus 1? That is root node count. Here internal nodes total number of internal nodes are 10 internal nodes plus 5 internal nodes, because 10 internal nodes of degree 2 and 5 internal nodes of degree 1, plus they are asking number of leaf nodes friends, L value. So simply here it is 20 plus 5, 25 plus 1, that equals 26. Here we are having 15. So L is equals to 26 minus 15, which is equals to 11. So that's why we got answer is equals to 11. Right friends, answer equal to 11. The same model question repeated multiple times in the gate paper friends. Okay, for example they mention like this. Suppose in a binary tree, if there are 200 leaf nodes, then how many number of nodes are having degree 2? How many number of nodes are having degree 2? Clear friends. Okay, so this type of questions also can expect. So based on the application you can solve the problem. Okay, I'll give 1 minute time. Can you post your comment in the chat box? Let me check the chat box friends. Okay, how many of you are posting answer? Let me check the chat box. Anyone? Yeah. So how to answer this type of question? Just apply previous formula only, friends. Okay. If there are 200 leaf nodes, they mention number of leaf nodes are 200, friends. Okay. And number of nodes are having degree 2 they are asking. Generally, in a binary tree, every node is having at most degree 2, friends. At most degree 2. Therefore, here they mentioned a binary tree. So you can consider there are I1 internal nodes are there. There are I1 internal nodes having degree 2. I1 internal nodes having degree 2. And you can consider I2 number of internal nodes having degree 1. Is it clear, friends? Number of internal nodes having degree 2 is I1. Number of internal nodes having degree 1 is I2. Then apply previous formula. The previous formula says that number of internal nodes plus number of leaf nodes is equals to number of internal nodes into value of k plus 1. I hope you remember the previous formula. In this case, there are two types of internal nodes, friends. One is I1 internal node, another one is I2 internal nodes. Therefore, we are writing it as I1 internal node plus I2 internal node. Plus we are having leaf node is L, which is equals to, it is also we are splitting in two parts. One is I1 internal node, another one is I2 internal node. Clear, friends? I1 internal node of degree 2. Degree 2 means every node is having degrees 2, that is nothing but k value becomes 2. Therefore, here we are taking k value is equals to 2, like as previous problem. And I2 internal nodes of degree 1, therefore here k value is equals to 1. Plus 1 you can consider, friends. Okay. Then this I2 and this I2 will get cancelled. So what we are having, I1 plus L is equals to, let me write here, I1 plus L is equals to 2I1 plus 1. From this L is equals to I1, because by bringing I1 to the right side, we will have I1 plus 1. What is the meaning of I1, friends, here? I1 means number of internal nodes having degree 2. Therefore, from this we can say I1 is equals to L minus 1. L is equals to 200. So, 200 minus 1, that equals to 199. So, in short format, in the exam, you don't do this calculation, friends. Okay. If they provided 200 leaf nodes, answer is 199. If they provide 500 leaf nodes, then answer could be 499. Just make it one less. Okay. If there are n leaf nodes are there, then answer to this question is simply n minus 1. So, this is the way we need to study data structures, friends. Okay. So, data structures point of view, actually my point of view, data structure questions are very simple by observing previous year ISRO papers, friends. Okay. And at the end, what I want to suggest you, if you want really serious about the preparation, you take previous year gate question papers first. Previous year gate question papers, there are two types of questions, right? 1 mark question and then 2 mark question. So, first to focus on 1 mark questions, friends. You read all previous year gate questions of 1 mark questions. Afterwards, while reading 2 mark questions, what you will do in 2 mark questions, what type of questions you need to practice? Maybe they will provide which of the following statement is true. They will provide 4 statements. Out of 4 statements, obviously 3 statements may be true and 1 statement may be false. Then you can collect all those true statements. Means I am not saying that only focus on 1 mark questions. You have to focus on 2 mark questions also. But how to read 2 mark questions means which of the following statements are true or which of the following statements are false. Sometimes they will ask 2 mark questions is match the following. So you can take match the following, right, friends? Okay. Or statements which are true or false, these type of statements we need to focus. Okay. So I wish you all the best. I am going to stop now. Okay. So this is the way you need to prepare the topic, and you need to prepare for data structures. This table is most important. Yes, this table is most important for tree concept point of view. Similarly, remaining like time complexity basic questions also is required. You can kindly refer the class notes which I provided here, or else if you have not yet attended regular courses, you can buy online course from the AS Engineering Academy also. We are having online courses for ISRO and GATE exam also. Okay. I wish you all the best. Thank you for giving the opportunity.